Grid Studio uses spatial sensor data to turn physical spaces, surfaces, and movement into real-time interaction. In this video, we're going to talk about how to work with 3D point cloud data, aligning that in 3D space, cleaning it up, and then creating clusters so we know where objects are, and some of the different things you can do in Grid Studio from that calibrated point cloud. So let's get started. First, you want to create a point cloud volume and add a sensor, the LiDAR sensor, and put it as a child object of that volume object. Once you have your input data and the sensor IP address configured appropriately and you're receiving data from the sensor, you can see we're actually seeing some point cloud already coming in from the sensor itself. A lot of the times, there are some different ways that you can actually visualize that point cloud. You can actually come into the display tab and actually change, for example, instead of looking at the source, because some LiDAR sensors actually provide color image as well from the point cloud. You can also change to a distance, so it is getting the relatively distance, so you get a sort of a band or a gradient depending on how far that point cloud is to the source of the sensor, or otherwise you can do a uniform color and define the color to be whatever color you want. So the next thing is we would want to start actually lining up that sensor. One of the tools that we would suggest people to use is to go into tool and actually just use a simple floor alignment. The reason being is that actually a lot of these LiDAR sensors are actually meant as a measuring device, so they already provide very accurate measurements in terms of distance and so on. With the floor alignment, you can very easily just use create 3 points, and that's all you need. And all you need to do is just come in here and pick 3 points in your point cloud that is going to be your floor. So I've picked this point here. You can see this is actually mounted, just the LiDAR is just placed on the floor. So things looks a little bit upside down, and we will, there are tricks to sort of compensate for that. So I'm just picking a few points that are a little further away, just so that it makes a more accurate and averaging things out a little bit better. So once I've picked these 3 points, then all I need to do is then just hit play, and you can then see that very neatly snap that and give us the floor alignment of the LiDAR system. So that's great, but you can see it actually sort of flips everything upside down. So one trick is that we can just very quickly take this LiDAR object, put it inside a folder object, and then we can then just do a simple 180 flip of that LiDAR, and then we can just move that back. And then we can then very easily just flip that LiDAR upside down, and then we are now just having the LiDAR sitting on the floor. So that is great, and that's already aligned up to my floor. And let's just say that, hey, I know roughly how my overall space should be. So I have this cube, and I just want to rotate that LiDAR just so that it fits within this expected space that I'm trying to get the whole space to be in. What you can do is make use of this object move alignment tool. And one thing to note, you probably want to orient and make sure that you are moving relative to the world and not relative to the object itself. Then you can just move the handles and just move that around. And we would just want to maybe rotate that just a little bit. And let's see, that looks pretty good here. And we might just want to slide that back just a little bit. And that's very roughly, you can already line things up. And of course, I can easily come in here into the coordinate system and just nudge these things around for more fine-tuned alignment. So here we have 2 more LiDARs, and by repeating the exact same process that I've just shown, I have now aligned all three LiDARs together in the same space. The next thing that you would want to do is defining basically where is your main tracking area. One thing that you can do under the volume objects, there are clipping objects, and we provide both an include and an exclude option. What you can do is then create these bounding boxes. For example, here I have an include box, so I can select that include cube. And now I have trimmed off just a bit of the walls a little bit over there. And that is roughly my main tracking area. What I can do is then I can also, for example, add an exclude box. And over here, I have another exclude box that is just right outside of it. So I can exclude all of that is outside of that. And this is saying that this is my main tracking area as well. So you can have both an exclude and an include, and always we will sort of do the subtraction for you as well. The next thing that you would want to define is then maybe to do a bit of cleanup of the data that is coming in. So we provide some input filters. Oftentimes it is like, for example, in this situation, we're getting a lot of the points on the floor as well. So for example, you can do a simple clipping option of the floor, and we will automatically sort of pick away from the floor. Of course, you can also use just simply defining your include zone and the include cube. You can just raise that up a little bit to exclude, so that it doesn't include the floor as well. But we also just provide you with a filter option if that's not what you want to do as well. The next thing then is you can also, another nice thing that we do provide is there is a background sort of subtraction process, and you can do sort of either a single frame or adaptive. A single frame is basically you can just take a single snapshot. So when you right click on one of the LiDAR, you can create a snapshot VBO, and you can then use those as your still background image or background setting. So often you would need to do that when your space is sort of empty, if you have that opportunity. Otherwise, there is sort of an adaptive mode where we will sort of throughout time, we are just sort of looking at what are all the things that are moving around, and then any things that are just sort of more stationary, then we can just sort of filter that out and say those are just static objects that are not moving around. So we're excluding those into the algorithm. And there's a bit of settings in terms of tolerance and then so on that you can define. Cool. So now that I've done some filtering and just cleaning up some of the data that is coming in, and we're getting nice clean data of all the people that are around the space, then the next thing you'd want to do is then create a clustering. So you would just do that, and you can then automatically see a lot of the people are moving around, and we are already drawing bounding boxes around the individuals. So now that we have detected all of the blobs and all of the people and objects within the space that we're tracking, within the volume objects, you can directly send those coordinate systems out to another destination. So under the maps output, you can then create a map output. And in this situation, I've already added a OSC object, and then I can directly just come in here and send those coordinates out as OSC messages. What you can do with the volume object or within our system is you can also create two separate zones or different types of zones. There's one called a presence zones and then another one called trigger zone. So let's just take a look at the presence zone. The presence zones is this purple one, and this would require the clustering to happen. And as soon as some of these objects have entered within this bounding box, then it gets detected, and you can see there's a visual representation telling you that, oh yeah, someone has already entered. And here you can also see some of the values saying that, oh yeah, someone has entered, and we are actually doing a count of how many objects or people are within that space. The next thing that you can do is the trigger zone. So this trigger zone is quite unique in the fact that it actually does not require any of the clustering to happen. It is purely just detecting whether any of the point cloud dots is within its detection area. So as the person is moving in, or we can very easily just move this in and out within these different spaces. You can see as soon as it touches any of those point clouds, or as those people are walking in and out of the space, or maybe even like they can put their hand out and their hand would be within that zone, then that could be a trigger and that can be sent as a message. So this is nice when you just want to have a touch wall using point cloud, and someone can just reach out with their hand and you can just create these very isolated touch zones and trigger zones. And someone can just move their hand and their hand is already within that area, then that would already send out a message going out to an end destination. Just before we wrap up, I would like to point you to a interesting functionality that Grid Studio provides. From the point cloud that we have generated and collected, it is possible to render out a depth map. So here we have added a camera object. I've just placed it just on the side. It can be quite useful if you just quickly switch over to that camera perspective, and you can then just sort of move around to the perspective that you want. And then after that, we can then actually look at how to actually generate that depth map. Under the volume object, you can see there is an option to add an additional input filter called image rendering. Often we would suggest you to sort of add this all the way at the very end of the chain, because you probably want to filter out your background, remove the floor, and so that any of those other points are sort of removed, and you're only looking at the resulting point cloud that you want. And then all you need to do is assign the perspective of the camera object. So just assign the camera object for the projection, and you would be able to get a image rendering out coming in here. And you can just go into the view to create a viewer, and we can see there is a image rendering here. Of course, right now it doesn't look like there is much. That's because the point cloud, the dot size are actually quite small. So if I just increase those dots and actually just bring up that viewer so that it is a bit bigger, you can see that we are actually rendering the depth map, and depending on some of the point clouds that are closer, they're brighter. The dots that are further away, they will be much darker. So this is a nice way to generate just a image feed from a specific perspective, and this can be then sent to something else to do some rendering based on the collected point cloud. So in summary, we've talked about how to receive data from a LiDAR system, placing that under a volume object, using the alignment tool to quickly align some of those LiDARs together. Then within the volume object, you can then include certain areas and exclude certain areas to very quickly clean up your point cloud, but then also applying various different filters to then further refine that. And then we can then apply a clustering to actually detect objects within that tracking area. Then you can then directly send those values out as a map output using OSC message, for example, and then creating presence zones and trigger zones depending on which ones you like to use. The presence zones will count the number of detected objects, while the trigger zone will only look at the raw point cloud data. And speaking of the raw point cloud data, you can also generate a depth map based on a specific camera perspective.